Consider the transformation W equal to Z plus 1 minus iota and determine the region D dash of W plane corresponding to the rectangular region D in the Z plane bounded by x equal to 0, y equal to 0, x equal to 1 and y equal to 2. So we need to find the region D dash in W plane corresponding to the region D which is bounded by these lines, right? So these are the given lines. Let's mark x equal to 0. This is your x-axis, this is your y-axis. This is x equal to 0 and this is y equal to 0. Let this be point 1, 0 and this be the point 0, 2. So x is equal to 1 and y is equal to 2. So this is a rectangular region D in the Z plane. Corresponding to this region, we need to find the region in the W plane, right? So this is the region D. Now we are having W equal to Z plus 1 minus iota. Making use of this, what is W? It is U plus iota V. That is equal to, what is Z? Writing this as x plus iota y plus 1 minus iota. That is u plus iota v is equal to x plus 1, collecting the real parts and the imaginary parts separately. And now if I compare the real parts, I get u equal to x plus 1 and v equal to y minus 1. Now we are having x equal to 0 and y equal to 0. For this we write the values for u and v. When putting x equal to 0, then y equal to 0, then x equal to 1 and y equal to 2. So u equal to x plus 1 and v equal to y minus 1. For x equal to 0, we get the value of u to be, if I put x equal to 0 over here, I get u equal to 1. And for x equal to 1, I get u equal to 2. To get the value of v, if I put y equal to 0 over here, I get v equal to negative 1. And for y equal to 2, I get v equal to 2 minus 1, that is 1. So let's draw the region in the W plane now. For x equal to 0, I get u equal to 1. This is your u axis and this is your v axis. For x equal to 0, u equal to 1. This is the point. Let this be 1, 0. And I get u equal to 1. Then for x equal to 1, I get u equal to 2. That is, let this be the point 2, 0 and u equal to 2 is this line. Then for y equal to 0, I get v equal to negative 1. So if this is 0, 1 and then this be 0, negative 1 and furthermore this be 0, negative 2. So v equal to negative 1 is this line and v equal to 1 is this line. So we are getting the region D dash in the W plane as this. This is the region D dash. The green colored region D in Z plane correspond to the pink colored region D dash in this W plane, right? So what we conclude from here? Let me also mark the lines. This is v equal to negative 1. This is v equal to 1, this is u equal to 1 and this is u equal to 2. So what we conclude over here? For every point in this Z plane, for every point in this Z plane, we are getting the unique points in this W plane, right? For x equal to 0, I get u equal to 1, the unique point. For x equal to 1, I get u equal to 2. The points are not same. There is one and only one point of the region D dash corresponds to the each point in the region D, right? So it is clear that this is one and only one. So it is clear that there is a one-to-one correspondence, right? So the conclusion is there is one-to-one correspondence. And because we are having W equal to Z plus 1 minus iota, so there is a translation of this D region, the rectangle D, in the direction of the vector 1 minus iota in the W plane. So that rectangle is translated from this D region to this D dash region. See, this is your Z plane and this is the W plane, right? This is a rectangular region D in the Z plane which is given to us, right? And there is a translation of this rectangular region in the direction of 1 minus iota. W is equal to Z plus 1 minus iota. This is the vector. So at what distance each point is moving? Each point is moving the distance square of the real part plus square of the imaginary part under the root. That is square root 2. So each point of D moved a distance square root 2. This point moved to a distance square root 2. This point moved to a distance square root 2. Square root 2. This point is also moved to a distance square root 2, and similarly this point. And this is parallel to the line. If I notice y equal to negative x, this point is parallel to y equal to negative x. This point is parallel to y equal to negative x. This point is parallel to y equal to negative x. Similarly this one. So we are getting the region D dash in W plane, right? So let's write this now. The second conclusion we get, there is a translation of the rectangle D in the direction of the vector 1 minus iota. That is, each point of D is moved a distance square root 2 parallel to the line y equal to negative x. If we consider the transformation in the Z plane only, right? Okay, let's move on to the next question. Show that W equal to iota Z plus iota maps half plane x greater than 0 onto half plane v greater than 1. Now what is the transformation given to us? It is iota Z plus iota. Just write W to be u plus iota v, right? And here it is x plus iota y plus iota. Solving this we get iota x minus y, because iota square is negative 1, plus iota. The real part is minus y, and collecting the imaginary part separately we get x plus 1 into iota. And this is your u plus iota v. When comparing the real parts we get u equal to negative y and v equal to x plus 1. Now what is given? It maps half plane x greater than 0. It is given that for x strictly positive, it should be mapped into half plane v greater than 1. Strictly greater than 1. Getting the value of x from here, we get x equal to v minus 1. So x strictly greater than 0 means x is what? V minus 1. This is greater than 0 or v is greater than 1. This is what is required. Yes. So for x positive, we get v greater than 1. Hence, we get the required result. Right? This is what is needed. For x positive, we should get v greater than 1. Right? Okay, thank you. Stay blessed.